Hi, Srini, how are you? How are you? So your class started or this week is a holiday, a break for you? Hello, hello.
Hello?
Yes.
Yes, hello, sir.
Is it a break for you this week or you have gone back to school?
No, didn't go back to school.
Huh? Not a break, ah?
No, today 3rd October.
Last week was
Sorry, today September, but then delayed what? So by right, 1 September became 3rd October already.
I thought last week was your trial exam. Then this week is a break.
Yeah,
Not a break, this week.
no,
Okay.
no.
It's your time now. What you want to ask?
Want to discuss everything, sir.
Just tell me the question number. It's up to you really, this last part of the revision. If you can do most of it, then you are doing all right. And then you look at the answer, it just help you. Whatever you don't know, it help you to know how to do it. Yep, question?
One teacher.
Number one,
Actually, I just want to go through everything, sir.
go through everything, okay?
Maybe I might don't know something that you don't, sir. So maybe it's better than me.
Okay, capacitance, at least 2 questions every year. Popular charging and discharging, can see there. Okay, charging and discharging, sometimes 3 questions. Okay, but usually there is at least 2 questions there. Okay, what's the answer for this one? Capacitance are variable. Capacitor can be varied from 250 to 3,750 microfarad. The capacitance of the capacitor is set at 2,000 microfarad and is connected to the power supply 12 volt. The power source is then removed. What is the maximum potential difference across the capacitance of the capacitor is varied again. Okay, what is the essential idea to solve this question?
Q equals to CV.
Essentially, you must know that
So 2000 times 12.
the charge is constant, because you remove the battery. So we are just using Q equals CV. Then calculate the charge. And then now the charge is constant. Now you can change the capacitance. You want maximum capacitance? Maximum potential difference. That means your C must be the smallest. Right? Charge stored is constant. Then V is Q over C. Okay. So your charge cannot change. That one, your charge. The smallest can go is 250 and you get 96 volt. Can? Okay. Anything not clear?
No, clear. Just give me 1 minute. So, but why did you do times 10 to the power 96? Can straight away do without that.
Huh? What resultant are you talking about?
No, because you see, just because 2000 times 12, you get 24,000 new F voucher. So you have to divide 250, still you get 96 for anyway. Or you need to times 10 to the power is the same unit, but
I suppose you can do that lah. Can do that because we are not interested in numerical value. We are just interested in voltage, that's all. So whatever you use, you will get the same answer. So you don't need to times 10 to the power minus, doesn't matter. As long as you
Yeah.
use the same unit throughout, yeah, okay. Okay,
Yeah, okay.
let's go to question 2 then. Two identical capacitors X and Y, which are connected in parallel to the battery and are shown in the diagram below. Which switch S is open? When switch S is open, the potential difference across X is V, and the charge store is Q, and Y is uncharged. When the switch S is closed, what is the potential difference Y across Y and the charge across Y? Okay, what should we do? What's your answer?
C.
C.
Mm.
Okay, what should we do?
Not yet.
Well, remember,
Don't know.
connected to a battery, so Y will be the same voltage. As you close the switch, the voltage will be the same. Yeah, that's the key important thing. The voltage must be the same. So how do you calculate that?
Q equals to
Close the
CV.
PD is still the same. It doesn't change because the battery you didn't remove. Since Y is identical to X, the charge store is the same. Huh? You're told Y and X are identical. That means the same value.
So if they were not identical means would have been, so
Not
just say
identical.
Y only.
Not
Yeah.
identical. Then you have to use Q equals CV. But in this case, your
Okay.
V is constant. No?
Oh yeah, because they say B same one. So yeah.
Okay. So
Okay.
this is a trick, nothing much to calculate. Just know what is happening. Okay, number 3. A capacitor of two parallel plate conducting plate which are separated by a piece of dielectric is fully charged by a battery as shown in the diagram. The capacitance of the capacitor will change if what is your answer?
A.
Okay, given dielectric is used. True. Capacitor is not fully charged. Capacitance doesn't change. Whether it's charged fully or not, it's still the capacitance is still the same. Battery of different voltage is used. It doesn't affect. Capacitor is constant. It only the battery will determine the amount of charge on the capacitor. Conducting plate of different metal are used. It doesn't depend on it. It depends on separation and the area. That's all. So false. So answer is A. Capacitor consists of two parallel plates.
Go back again, Jay.
Okay.
Okay. Okay.
Capacitor consists of two parallel plates in which the distance between the plate can be adjusted. Capacitor is charged by connecting the capacitor to a battery, which is then removed. The potential difference between the plate of the isolated capacitor can be increased by, okay, remember, the charge stay constant, remove the battery, there's normal potential difference, is only the charge constant, the potential difference is not constant. Right? You charge the two plate, you discharge it. Right? Remember your formula. V equals to ED. The charge stored is constant. So that force touching the plate will discharge capacitor, and it will end up with a zero charge. Bringing the two plates closer, right? Use the formula. C is just that, bring the plate closer. Remember, your Q is the one that is constant. Your V is the one that can change. Area is constant. Closer, this one is smaller. You want to increase it, so that's the right answer. A is false. Right, sorry. Bringing the plate closer, this is smaller. Bringing the plate closer, you are increasing the capacitance. So you want to keep your Q constant. Right? So that one will decrease. So false. Separating the two plates further apart. That means you are moving this one further apart. The capacitance will decrease. So your V will have to increase. Allowing the potential difference increasing by itself. It cannot increase by itself unless it's connected to a battery. So false, impossible without a source. Okay, unless you adjust the capacitor. Okay with that?
Okay.
Any comment?
One more favor, Chair.
Yeah.
Do you know the last time the Ace Ahead, right?
The what?
The Ace Ahead, the question, the reference book questions.
Okay.
The one teacher used to discuss one. If you don't mind, right, Chair, can you send like the answer scheme for the exercises? Chair? There's some like a bit confusing. At least when I see answer, then I could understand or something. Can send Chair, for all the chapters.
It's up to you to ask. Which question you want to ask is your time. Now it's a free time already. It's up to you.
No. I mean, teacher send everything because like I just want to see whether I understand it or not. That's all.
You just tell me.
If I don't understand, then I ask teacher lah.
You just ask. That's all. It's your time. Okay. So if not, I will.
No. The one in the Word, the document, all you keep. That one I'm asking.
I'm not sure what you're talking about.
No, because when you discuss answer, right, teacher?
Yeah.
You do a PowerPoint, right, teacher, for all the answers. That's why I'm asking.
Yeah.
No, that's why I want. I mean, like, because the hard questions, like if I get confused, then if I see the answer, then I understand. If I still not understand it, then I ask. I prefer that way. That's
Then it's better
asking.
for you to ask me question rather than I go through every question. Only those questions you are not sure.
Oh.
You don't have the time to answer all the question. You have to try the structure
one.
and the essay one. That's the most important one. You are not doing your homework. That's why I know. Okay, any particular one you want me to show you rather than go every question? You don't have the time.
No.
Unless you want to come an extra hour.
Next question.
You should put in the effort, as I said to you already. Keep on scolding you. If you put in the effort, you won't do well.
Keep on putting the effort.
Number 5, parallel plate capacitor with dielectric is shown in diagram below. The charges on the capacitor are plus Q and minus Q. Which statement is not true about the capacitor? The electric field between the dielectric is uniform, normal uniform, right? The charge will be polarized. So there will be an electric field opposing the direct electric field. The electric field between which statement is not true? The electric field within the dielectric is uniform. Okay, it's uniform, but it's opposing the actual one. The electric field between the plate is dependent on the net surface charge density. Right? Look at the true. Right? The electric field between the depending on the net surface charge density. Right? Area affects the capacitance and the charge density. The induced charges on the surface of the dielectric are equal in magnitude to the charges of the capacitor plate. Right? As I said, the dielectric there will be induced charges here, it will be opposite to that. So if this is negative, this part will be positive. This positive, this part will be negative. So false. Right? It's opposite. Induced charges are less than the capacitor on the plate. Right? Not every charge on the plate will induce a charge there, because there is more charge on the plate than on the dielectric. Right? The atom occupy more space than the electron. Remember that. So the electric field due to the induced charges is in the opposite direction to the electric field due to, okay, this is correct. Right? You oppose the direct electric field. The answer is C. Okay.
Okay.
Dielectric is inserted into an air-filled capacitor plate of capacitance 20 microfarad, so that only half of the space between the plate is filled, as shown in the diagram below. If the dielectric constant is 5, what is the final capacitance of the capacitor? Okay, how are you going to solve this one? Yep. Any idea how to solve this one? Yep.
This one.
It becomes a parallel capacitor now. Right? Two parallel capacitor, because these are potential difference is the same across
C, the answer is C.
What's the point of telling me? You look at the answer, you don't know how to do. So it means that half of it, the bottom half will be 10, and the
The
top half
other
will
half will
be
be 10.
the top half will be 10 times 5. Right? So the capacitors are in parallel, that you must know. Capacitance of the air-filled one will be 20 divided by 2, because you have taken half of it, so it becomes 10. And then the capacitance with the dielectric, the top one, times 5, so it's 50. So it's parallel, you just add them up. That's how I get the answer. Okay.
Okay.
A parallel plate capacitor is initially charged by a battery, and the battery is then disconnected when the dielectric is removed from the charged capacitor. Okay, key is parallel plate capacitor initially charged by battery, and the battery is removed. So keep that in mind, battery is removed, so the charge is constant. When the dielectric is removed from the charged capacitor, the charge stored in the capacitor is increased. So you can increase the charge. Charge stored is constant. That's a key important thing you must remember. Energy stored in the capacitor increases. Right? Go to the formula. The charge is constant. You cannot use CV square, right? Because you have when you remove the dielectric, you are changing C and you are changing V. So you cannot have two variables there. Right? You have only one variable, then you can see how it behave. So Q is constant, C decreases, so energy increases, so it's true. The potential difference between the plate decreases, right? Q equals CV. C decreases, you remove the capacitance, you remove the dielectric, the capacitance decreases. C decreases, V increases, so it's false. The electric field strength between the plate decreases, false. Right? E should increase. Okay. So answer B. Okay or not? Okay or not? Okay.
Okay.
A capacitor with an air gap between the plate is connected to a battery. The battery is then removed from the capacitor. Same as before. Charge is constant. The dielectric is then used to fill the air gap between the plate. Which statement is true about the capacitor with the dielectric? Energy stored in the capacitor increases. Right? Taking the battery away, remove the source of EMF. That's a key important point to remember. So the charge stored in the capacitor is constant. Adding a dielectric increases the capacitance, decreases the potential across the capacitor due to polarization in the dielectric. Sorry, it should be polarization. And energy formula, remember the energy formula, U is half Q square over 2. So yeah, putting dielectric inside. So I'm going to increase the capacitance. Right? Increase C, energy store will decrease. Right? So C increase, energy store will decrease. Electric field strength decreases. Yeah, because there is electric field strength from the dielectric, right? Due to polarization of the dielectric, so the net electric field strength decreases. Q is CV, Q is constant, and C increase, V decreases, right? Or electric field strength decreases, your V will decrease. Answer is C. Okay. Okay. Anything not clear? Two capacitors which have the same capacitance can be connected in series or parallel. Which statement is true about the charge stored for the same DC voltage? Okay, the voltage is the same. Okay, I told that series connection stores amount of charge twice that of parallel connection. Okay, remember when you store in a series, the voltage across each capacitor is shared. Not the power, not the DC supply. So the charge store is going to be smaller. Right? Store less charge. Whereas in a parallel, the voltage is the same. So you can store more charge in each plate. Parallel connection stores an amount of charge twice that of the series capacitance. False. For series, the charge on each capacitor is right. Remember the two capacitors have the same capacitance. So in series, then the charge stored in each is half CV. Total charge stored is CV. For parallel connection, the charge on each capacitor Q is CV. Okay? C is the same. B is the same. So total charge is 2CV. Ken, are you with me?
Yes, I'm with you, sir.
Right? Because here is C, but the voltage is half. That's why we have a half there. So you can see it's not double. The series connection store an amount of charge 4 times. Right? Cannot. Right? We have argued that already. False. Parallel connection stores an amount of charge 4 times. Yeah. You can take and you can divide this one, divide by that one there. True. Okay. Answer is donkey. Anything not clear?
Oh, okay.
You need to put an effort to learn. If not, you are wasting your time here. I have to do every question for you. You're not learning anything. Parallel plate capacitor is fully charged when an insulator is inserted into the space between the plate of the capacitor. The energy stored in the capacitor decreases by 73%. What is the value of the dielectric constant of the insulator? Okay, remember the dielectric constant is where you capacitance where you have dielectric divided by capacitance when you have air or vacuum. Charge stored in capacitor is constant, right? Fully charged. Charge stored in capacitor is constant. So you have to use the energy formula. Initially, right? Initially is Q half C naught square. And finally is half Q with the new capacitance. Right? Q is the same. Then you divide. Final one divide by initial one. That's the final one. That's the initial one. The Q square can cancel off. Half and half can cancel off. So you get C naught over C goes to 0.27. Remember 0.27 left. Right? The amount left is 0.27. You compare the final one to the initial one, the amount left is 27%, not 73%. Right? So you have got your C naught over C. So you want this dielectric constant, right? Or epsilon R is just the inverse of this one. That's why we set reciprocal and use your calculator. Answer is C. Okay.
Okay.
Parallel plate capacitor with a separation of P which is fully charged by a battery to charge Q, right? Q1 and minus Q1 is shown in the diagram below. The battery is then disconnected. Sun is removed from the capacitor, and the distance between the plate is increased slowly. Which graph shows the variation the charge with X? Remember, you remove the battery, the charge is constant. So what is your answer?
The answer, donkey, sir.
Okay, we have to change in 10 minutes time. I think we cannot go too slow. You are wasting your time. You're not going to do your homework. You have to go to structured question in the next half hour. Yeah. Sorry. Trying to remove the charge is constant. It doesn't change with distance. So the answer is A. Can change the distance, it doesn't change the charge. You only change the capacitance and the voltage, that's all. Okay, we have been going over the whole earlier also. The plate of an isolated charge capacitor are pulled further apart. Which statement is not true of the capacitor? Capacitance of the capacitor decreases. Go to your formula. That formula. You pull it far apart. That one increases. That one decreases. So it's correct. The energy formula. You cannot use CV square because charge is the one that's constant. Can only have one variable there. C is a variable. Okay, so true. As C is inversely proportional to D, D increases, C decreases. Energy stored in the capacitor increases. Right? Your C decreases. The energy increases, correct? The charge on the capacitor remain constant. Yeah, that's true. The potential difference across the capacitor remains the same. Right? Cannot remain the same. Your Q is the one that's constant. Your C decreases, so V must increase. Okay, so the wrong answer is donkey. Okay. If okay, let's go to the next question. When a parallel plate capacitor is charged to a potential difference of 12 volts, the charge on each plate is given there as a charge. If the potential difference across the capacitor is 30 volts, what is the energy stored in the capacitor? Right? C is Q over V. Calculate your capacitance. Right? Basically, you are using the same capacitor. You are changing the voltage also. So first thing is to calculate your capacitance. Right? Energy store formula. Half C is just that. I've done something wrong. What is happening here? Sorry, there's something wrong here. There's no 2 here. Okay, can? Answer is C. 1 or 2 more. Which graph shows the variation of energy stored U in the capacitor with charge during the charging process?
A.
Right? Remember your formula, your charging process, your C is the one that's constant. Charging process, the charge will change, the voltage will change. So you cannot use a formula where both are changing, only one allowed to change. So here you are interested in energy and the charge. So as the charge increases, energy increases. Right? A. This one is a polygon graph. Right? Should be slightly to the right. Right? This part, not vertical. Capacitor is connected in series with a switch. Okay, what's the answer for this one? Discharging. Which graph represents the variation of current with time during the charging process? Right, memory only A. Right, this one is a bit far out lah, unless it's further down a
Too
bit.
far out.
Too far out. So answer is right. If it's charged, then it's C. Memory work. Right, charging current is large initially. As the capacitor, as the charges build on a capacitor, the charging current decreases. Right? That's the formula. A. Okay, last one. This one. What is the time constant? Right? If you know the formula, use the formula. If not, doesn't matter. Then you can find the time constant. If not, go to the form, the the uh the discharging current, right? Here by I naught. And then look at your right, this one. This one is halfway, 50% or half. And then you got 1.4. Right? This one we don't know unless you can estimate. This is probably your RC, I think. Then calculate out 20.2 seconds. Okay. Okay, we'll give you 5 minutes break. You can try the question, those you have not tried, so that you can ask me rather than waste your time. You want to go for a break? Go ahead. So I will stop here. And after that, you should have question to ask.